After completing this lesson, you'll be able to create an exploded view of the assembly, capture snapshots of stages of assembly, create output for use in publishing tools, and export an animation of the assembly process. A presentation file can be used to generate exploded views of the assembly. As part of the process, the changes made to the assembly are captured in the storyboard at the bottom of the screen as events over the course of time. These events can overlap and they can change in duration. You also have the ability to capture snapshots and save those snapshot views in the files as well. If you move the playhead through the process of assembly, you can capture snapshots of the partial assembly or disassembly process. And at any time, create a new snapshot view. This snapshot view can be exported for reuse in technical publishing documents. The process of creating an animation begins with creating a storyboard. The storyboard can be clean with a fresh start, or start from the end of the previous storyboard so you can create a series of exploded views. We'll start with a clean storyboard. This will give us our complete view using scene 1. It's also possible to create a new scene. Using the same assembly file, we'll go to Options and change the design view to be of the gear train. We can also choose whether or not changes made to the gear train view representation in the assembly will affect the views that we create in this presentation file. If we want that, we can leave this associative. We'll click OK and Open to generate a new scene. This new scene will give us the components that are visible in the design view. We can begin by creating events that move the components around called tweaks. We'll start with the backside of the pulley. Using the Tweak Components tool in the panel, or with a right click and using Tweak Components in the marking menu, I'll select the first component that I want to tweak. It will pick up its coordinates from the component itself, though we can override how those coordinates are established. We can also set a duration for a specific event, or just keep using that duration, I'll use 0.8, as we create additional events. First, I'll grab the arrow and move the nut out roughly 2.5 inches. Then holding Control, I'll select a washer and begin dragging it out roughly 2.5 inches. After creating the first move on the hex jam nut, it created an event that ended just before 1 second, that was 0.8 seconds long. As I hold Control and click the spring, it will record the second event that I made, moving both the circular washer and the jam nut. Let's continue doing this, moving each of these around 2.5 inches and picking up the components that are mounted to this shaft. I'll make this move just a little longer and then pick up the friction material and then the hub. After beginning to move the hub, I want to click OK to record that event and start a new Tweak Components event for moving this pin out of the way before I begin gathering up the bearing. I'll slide the pin out a distance, click OK, and start the Tweak Components tool again. I can safely relocate and reselect the components that I've been choosing, and it will just create a new event. And then let's move the bearing off the end of the shaft. Let's click OK for now. Let's make 3 more tweaks, and then we'll pause for a moment and take a look at what we have. First, let's grab the R-ring that retains the bearing, move it out, then grab the bearing, and then we'll grab the gear and slide it out as well. Okay, Now we have a fair number of tweaks. In fact, if we resize the storyboards panel, we can see all of the events that we have. We can rewind back to the beginning and click play, and it will go through the events on the screen as we made them. At any point, we can go back and make tweaks. So for example, moving the hub, I moved it out a short distance. Let's edit that tweak and move it out just a little farther to give more clarity around the tweak of the pin. Now, when the bearing and all of the other components begin moving, I want that to coincide with the movement of the pin. So by holding Control and clicking the events, I can change when that event occurs. Now, if we go back and play again, we can see that pin slides out just in time before the bearing comes through. Now, the next thing I notice is picking a point in the timeline and beginning from there. All of that happens, and then we have our bearing and retainer from below. But what if we were to take, and again, using Control to select these events, let's move these forward in time so that they coincide with the motion in the upper shaft. There. That works pretty well. Now let's take a quick look at the other side, and we'll just make a couple of changes. Let's take our timeline and move it back to where we're starting so we have a good reference. Let's again tweak. We'll grab the key, pull it out of the shaft, start another tweak component, begin moving the retaining ring out, then both bearings, and then a distance out, let's drop off the upper bearing and continue on with the lower bearing and retaining ring. Now let's take a look at that in total. All right, that looks pretty good. Now at the beginning of our timeline, this is a good view of the assembly. It gives us a clear view of the hub, and we want to be able to explain to people that beneath the hub is the friction material pressing up against the pulley. So let's go ahead and let's record a snapshot of that assembled view, and then let's move the animation to the end and get a good point of view of the assembly where we can clearly see all of the components. Let's do a quick snapshot of that. And let's go ahead and make sure that we end up in this point of view in an animation. So we'll capture the camera at this point in time. So if we move back to the beginning of the assembly, let's move this storyboard down a little bit so we can see a little more clearly. We'll start with this point of view, and then roughly at 1/2 second, we want to pivot around to where we can see the nut beginning to be removed. And let's capture that view. Let's go back to the beginning. Let's move the playhead to the scratch area where we can establish an initial point of view of the assembly. Capture that camera in the scratch board. All right, and then let's play. It transitions over here. And then those components start to go out of frame before we can clearly see what's happening. So let's go back to the point where everything starts to get stretched out a little too far. Zoom out a little bit. Capture the camera again. Let's stretch this out just by hovering near one edge and clicking and dragging to lengthen that transition. And then as we get to where the backside is being animated, let's change the point of view again to see what changes are being made on this end. Do another capture camera. Extend that out. And let's rewind again. Hit play. and see what the animation looks like. Okay, needs to go out just a little bit farther at the end, so let's move the playhead to the very end. Zoom out a little bit more and use capture camera once again. This time what we'll be doing is updating this camera. So as it plays, it extends out, and then we'll hold that as well. That will be the end of the animation. All right, so now we have our beginning view and our end snapshot view. Let's go ahead and export those as raster images. We'll go with the selected views, or we can say all views. We can go with the current window size, set a resolution. Let's go with a little higher resolution, maybe 150 pixels per inch. Set the path and choose the file format. We can use bitmap, GIF, JPEG, PNG, or TIFF. And another added benefit, if your design window background is color and you don't want to use color in a technical document because it will be wasting ink and it can be distracting, you can select for a transparent background. Let's click OK. This will generate our raster views. And we can then also say that we want to export our video. We can use all storyboards, the current storyboard, or we can even set a range within the storyboard. Let's do the current storyboard, but let's reverse it. We use the current window size, or we can select a specific resolution. Although with my screen resolution, that would actually be larger, so we'll go with the current window size. We can give the output a name and choose whether or not we want WMV or AVI. We'll click OK, and it will generate the video file using the selected codec. With the raster image and the video created with a more realistic look, let's create another image that's more suitable for a simple technical illustration. Going to the browser, let's expand the scene and then open the assembly that the scene is based on. Once the assembly opens, let's activate the gear train view representation and then create a new representation we'll call illustration. This new representation will look like the gear train because that's what was active when it was created. For this new representation, I want to eliminate the color variation, so I'll select all of the objects in the assembly and change their appearance to ceramic. This will give a more unified appearance. Now, we can reactivate the full assembly representation just to show that the changes that were in place before are still there. Saving the assembly and closing it, we'll return back to the presentation file where we could create a new scene, but instead I'm going to right-click on the scene and change the representation to illustration. This will update the look of the model and the scene. And then let's go to the end of the timeline so we can see the full exploded view. Finally, we'll go to the View tab and change the visual style, selecting from all the options. We'll pick Technical Illustration. This will further simplify the color, but there's one more step. Under Shadows, we'll deselect all shadows. This will give us a simple, more line art looking representation of plain white objects with black edges. Now let's return to the Presentation tab and create a new snapshot view. Once it's created, let's rename it Illustration. And then export that raster image using the same resolution and with a transparent background. Once it's saved, we'll go to a Word document or any other publishing software and import the image and see that we have a nice clean illustration of the product. And just for reference, let's take a look at that animation output of the assembly. An added feature of the presentation file is the associativity to the assembly, so that should the assembly change, the presentation file will update and make it very easy to keep all of the technical documentation you need up to date.